Hello, everybody. Have a good day. Happy New Year out there, and glad you can attend. So with that, we'll start the presentation. Today, we're going to talk about private clouds, public clouds, various different configurations of clouds, such as platform as a service, software as a service, and so on, the benefits of each, and when and where you should pick what type of cloud. This can apply to all clouds, but specifically we're also talking about VAI's clouds because we offer some benefits because we only host our actual applications. One of the big benefits, I'll start here with our cloud, is we always include high availability and disaster recovery. But I'm going to go through all the details of the various different clouds, differences between each models, and something that's high at the top of everybody's mind today is security in the cloud and whose responsibilities are for each particular model. And with that, I will move on. This is somewhat of a famous quote that goes back to 1961. So people have been talking about cloud and when computing is going to become utility-based, and it's arrived quite a while ago. And in the case of all versions of cloud, whether they're private or they're public, hybrid or not, they all follow this model where they're pretty much a utility-based service. This is just a quick recap, on what cloud computing is. From the standpoint of computers, traditionally you'd buy a computer, it's on-premise, you manage it yourself, whatever capacity it is yours. With cloud computing, done correctly, it typically is going to be utility-based. You can scale up and scale down. Costs should be reduced based on the fact that the costs are spread across many different consumers or businesses or individuals using cloud computing. Obviously, much of the technology is managing it is thrown back onto the providers, whether they're cloud service providers, managed service providers, and so on. This just goes into a little bit more detail, and that's when somebody goes into the cloud, there's various different controls and sizing that controls how much resources it can be used, and to make sure that there's always resources available for everybody that's in a cloud, whether there's hundreds in the cloud, thousands or millions in the cloud, and various different models based on user headcounts are appropriately supported for cloud computing. This just goes through some of the cloud computing today. I'll just do a quick recap when people talk about the term cloud and terminology. Everybody just says the cloud. That's a colloquial term just referring to about everything, and it goes back to the frame relay and X25 days where sales reps and engineers used to just draw a cloud on there and just say everything connects through here, and you don't care about what's going on under that cloud image. Well, today it's got a little bit more technical meaning, and we can dive more into how the cloud actually works. There's a term cloud computing that refers to how you pay for the cloud. It's an acquisition model, SaaS, software as a service, platform as a service, infrastructure as a service, and I'll cover that as we go through this. Then there's the architecture of how you build the cloud. There is actual architectural frameworks, and it does build upon highly scalable servers in the cloud, SANs, virtualization, scalabilities, stability. You should gain stability by moving to the cloud, and it allows you to, levels of resiliency if you build in high availability and so on. And I'll go through, the various different ones, public, private, and hybrid. This just shows that diagram that I showed before with the picture of a cloud and all the applications that are sitting in there. And then all the devices today that you might want to connect to that particular cloud platform. And that cloud platform that I'm showing on this screen here could also be hybrid, where they're not all sitting in one cloud. Like I said, we host our applications in our cloud, but we have customers in our cloud that might need to connect to other clouds. It's very common, I think they all do, whether they're for other software services, whether we're hitting APIs from other clouds out there, or they have other applications on Microsoft's Azure or IBM's cloud or Google's cloud or so on. Here, looking behind that, this just goes into some of the details, benefits, types of various different clouds and the clouds that you would have in there. From the standpoint of, all the different technical details that are in there, I'm not going to jump through all of these, but, from the standpoint of what it compares to, your stakeholders, benefits, whether things are local, whether you have some local equipment, hybrid connected to a cloud, and so on. And that typically is going to be how a lot of people today work, is in a hybrid configuration, whether they realize it or not. But specifically, I'm going to go through things like private, public cloud, and, from the standpoint of tenancy, whether it's single tenancy at the software layer or multi-tenancy also at the software layer. As I mentioned, from the cloud computing models, infrastructure as a service is where the cloud provider provides all the hardware infrastructure. They usually are going to provide all the hypervisors and everything else, and you might provide the operating system and then all the applications that sit on top of it. There's still some providers out there that might actually provide bare metal platforms for you, where you actually have that whole server dedicated to you. Then there's platform as a service, which is where VAI, the bulk of where VAI's customers sit. We do have a few software as a service customers, but the bulk of it is platform as a service. And I'll go through and show the differences as it's coming up. But from the standpoint, all the hardware, software, operating system, everything is provided by the platform as a service provider. The application software is provided by who's ever going into the cloud. And software as a service, which everybody should be familiar with, and that's typically always usually in a multi-tenant, public internet-facing situation. The end user owns nothing. They're paying for the software per user per month, and potentially on a metered basis also, based on how much capacity, bandwidth, so on and so forth. And here I'll delve into the other payment methods in some future slides as they come up. This shows in a visualization what I was just talking about. Your private on-premise systems, and the term private is used in various different methods. There are companies who create their own actual private cloud. I'll show where the definitions come up in that situation. But traditional on-premise is all private. You manage it. You manage everything from ground up all the way up. If you're doing infrastructure as a service, you're managing what's in orange, and the cloud provider is managing what's in blue. Platform as a service, you're seeing from the standpoint of blue, the cloud provider is going to be managing everything there. The applications will still be managed by you, and in most situations, platform and service, almost all of them, you would have access usually to the operating system also. And on the last one, software as a service, everything's managed by the provider. And as I mentioned, the key point on platform as a service is for software as a service, you don't get access to an operating system. If it's browser-based, where it's public-facing on the internet, many times you wouldn't have access to any equipment on your network or any shop floor control or any kind of conveyor systems and things like that, unless you went through some sort of custom configuration through a provider like that. But typically, that would not be software as a service then. Clouds are built based on standards. This is not showing all of them, but it's showing a sampling of some of the standards that how clouds are built. There are standards, there are, recommended configurations and so on and so forth, and security. And security is one of the biggest ones that you'd want to be following all the standards for clouds. There are actual definitions of cloud computing, and these are the only official ones from the National Institute of Standards and Technology. Anything else that you're hearing as a service is a marketing term made up by a company, like backup as a service or something like that. That doesn't have an official definition of this. But this goes through, and when you get a copy of the presentation, you go through and read all the details on here. But software as a service, as I mentioned, usually as a multi-tenant configuration, you're accessing it through a public-facing interface. Platform as a service can be public-facing, but it also can be private-facing. In the ERP world, just about all of it, except for the smaller ERP providers, would be all private platform as a service usually. And infrastructure as a service usually you're using for something other than the, ERP. Usually it could be for development, for special projects, or you want to manage the whole stack yourself. Many big providers and like many of the streaming services use infrastructure as a service for a lot of streaming services, and many other services out there use that where they're maintaining all of it themselves. Going through official definitions also, private cloud, as I mentioned earlier, could be something that a company owns themselves, like if you're a Citibank or something like that, you're using cloud computing, but you might actually own all of your equipment is in the cloud, but it still might interface to other clouds. Or it could be managed by someone else, or it could be someone else, like in the case of VAI, a third party who's managing the cloud for customers. Community cloud, that's a unique one where if you're in an association or trade group or something like that, where you might actually join a cloud, whether it's for softwares or for marketing or various other, communications or collaboration tools, that's a community cloud. Public cloud, as I mentioned before, is usually something that's operated by another entity, usually, but it has a public-facing interface. And then hybrid cloud is any combination of the above, on-premise, private, public, so on. It pretty much covers all of them, just communicating together. Here, as I mentioned, private typically is you have your own intranet. This is applicable for large enterprises, businesses, for certain types of applications. Obviously, if you're running payroll and using a payroll service, you're going to be hitting a public interface, and a variety of other services and things like that might be public-facing. But something is line of business critical as ERP, that's typically going to be on a private cloud. Like I said, except maybe for some of the smaller offerings, some providers where they might do some SaaS-based public-facing ERP applications. And hybrid, as I previously mentioned, is pretty much a combination of any types of communications that have to happen between clouds. Here, just going into some examples of the architecture. I'm not going to cover everything. This is very high level. But you're virtualizing things like memory, cores, storage, disks, so on. It's happening on SANs. There's a lot going on behind the scenes of levels of redundancy. In our cloud, we always have much more capacity than what we need, just for the ability to pick up running, moving instances using, virtual machine mobility and moving them around from various pieces of equipment when things need to be done without interrupting operations of customers. Same thing with SANs. The SANs, there's a lot can be done from the standpoint of, doing SAN level replication and things like that are happening under the scenes. Also, the networking and with the security and access controls, that's all done to secure things up in our cloud. We do platform as a service. You get your own operating system instance. You're not multi-tenant. And you're segregated for all other customers there. We do what's commonly known as north, south, east, west firewalling, since everything going in and everything going out is inspected by firewalls, and any communication between servers in our cloud are actually inspected also. Plus, with clouds, you're always going to get redundant levels of power generation capabilities, multiple power sources, multiple ISPs, using as an example here, border gateway protocol, that if one of the ISPs at a cloud is having issues, it can switch over to another provider in there, and you're still operating. There's also other things like hypervisors are always in use. There's various different ways of deploying cloud also, whether they're, we use Power VM, VMware. There's other things like cloud native that we're using also from the standpoint of containers and things like that. And this just goes into, from the standpoint, a cloud is built with, computing equipment that is known. They're using hypervisors and operating systems that people are aware of and things like that. You'll see a lot of Linux that's out there. In fact, in a competitor's cloud, Microsoft Azure cloud, actually there's 53% of their cloud runs Linux. and it's not dominant Windows anymore. It hasn't been for quite a while. And they do run other operating systems like IBM operating systems and AIX and various other versions of Linux and so on and so forth, including their Windows also. And this is the model for most clouds today, that they're all highly virtualized, but I did mention that there are some instances where somebody might want to use bare metal, but it's available but not commonplace. Provisioning, this gets into something that's specific that needs to know from the standpoint of public versus private cloud, but provisioning is what's done to create these environments for where software is going to run. From the standpoint of what type of applications are going to be put there, the securities, and various different things like that, and who actually does the provisioning, which I'm jumping into here. In the case of a private cloud, where there's no public-facing applications other than, say, e-commerce or websites, things like that, that's typically all standard for a private cloud. You're using either IPsec tunnels or tunnels from all your various locations, or even private circuits in some customers, or they might use an SD-WAN service that connects to the cloud. But either way, the access to the software is not through a public-facing interface. For some critical applications, even with multi-factor authentication, that's still not considered secure enough. And the private cloud, as I mentioned, can be internally owned, but typically today it would be owned by someone else. It would be an external cloud provider that you're going to. From the standpoint of security, whether it's software as a service and platform as a service, software as a service, I mentioned, security goes all the way up to the application layer, and usually you don't have that much options in configuring the applications either. Platform as a service is a combination of security being provided by the cloud provider. Like in our case, we're still securing all the applications that are public facing and everything that's there, but you maintain the security on the S2K application. And as I mentioned, with private clouds, usually, except in the case of SaaS, you're going to have access usually to the operating system at some level. In public cloud, and originally I had this on 2 slides, so I put it together so you could see it on 1 slide. On a public cloud, you have a public-facing applications, whether, today we shouldn't be using anything that doesn't have multi-factor authentication if it's a critical application. And public cloud is externally owned. It's usually not something that you're owning. And in the case of public cloud, as opposed to private cloud is usually provisioned by the private cloud provider, whether it's your IT department or, as I mentioned, the cloud provider. In the case of many public-facing, not all, but many public-facing, the provisioning is you logging into a website, filling out how many parameters, filling out parameters on the screen of how much gigabytes you want of disk, how much memory you're going to need, how many cores, and many times you're having to know and figure that information out, have somebody assist you in how to configure that. Or you might be paying the cloud provider to assist you in sizing that for you. But that's provisioning that's usually public-facing, and a big difference between private and public. And also from the standpoint, depending on what type of public and private, what public acquisition model you're using, whether it's platform as a service, infrastructure as a service, there's certain levels of responsibility that would typically fall on an end user's shoulder. Like in platform as a service, where the infrastructure is managed by the cloud service provider, you still would probably be required to secure up your applications that are public-facing and make sure you've got your public-facing applications configured for the highest levels of security. And in the case of infrastructure as a service, that typically would always be falling on who's ever deploying in that situation. There's still a network operations center and a security operations center where they're monitoring networks and the security inside their network, but there will be some security that falls on an end user's shoulder. And in the case, as I mentioned, SaaS-based applications is always managed by the cloud service provider. And obviously, I mentioned again, also operating system access is not usually available for SaaS. And here, I'm going to go through some of the public facing. Typically, it's all multi-tenant, and it's pretty rare that it's not going to be multi-tenant, but there are certain situations where you might have SaaS, and you could request to have, and this usually is in software development, where you might want some level of dedicated resource. But by and large, if you're public cloud, it's expected a lot of it's going to be multi-tenant. And meaning your applications, which is why you can't have access to the applications, because many different tenants are in there. So, and you obviously couldn't have access to the operating system. This just goes through the various different things. Metered billing is prevalent in public cloud, where it's going to, which is based on your capacity that you're using, disk capacity, RAM capacity, CPU capacity. You might be billed based on how much you're using, also bandwidth, how much bandwidth you're going in and out on. For certain things like quick software development projects, it can be advantageous to use something that's metered billing, especially if it's matter of a few individuals. If you're doing something like an ERP application like ours, that can tend to be very expensive. Also, in the cases of public cloud, they don't include HA. If you're doing HA, you're having to set up different instances, and maybe they're different cloud locations. If some might offer some ability and some tooling to allow you to replicate between the data centers, others, it might, especially in the case of infrastructure and the service, it would be up to you to provide the replication high availability applications in your apps, in your software stack. This just goes through, from the various different bullets that are different in public cloud or specific to public cloud. As I mentioned, a lot of the infrastructure maintenance and everything else is done on a SaaS PaaS by the cloud service managed service provider, but a lot of the infrastructure service security is maintained by the hardware is maintained by the CSP MSP, but the end user is responsible for security. And security responsibilities is different based on different cloud providers from the standpoint of, especially in infrastructure as a service and in that situation. Private cloud, typically in the case of ERP or something like that, you're going to get your own operating system instance. You're not going to be doing multi-tenant at all. There might be some situations where it would be multi-tenant and it's still private connections. There are a few situations where you do that, or you could request from a SaaS provider to have a private connection to them. Or request from a SaaS provider to do a custom configuration that gives you a single tenant situation, but your cost usually with that type of provider would go up dramatically. And here, from the standpoint of the cloud pricing, there's various different pricing models. In the case of private, usually it's based off a contract. And then who the cloud provider, that contract might be metered or it might be flat rate. So in the case of VAI, when we size it, it's going to be sized to a particular size, and it's flat rate. It's the same amount every month until you need additional capacity in there. And we do offer you the ability for you to burst up during busy seasons and things like that, and add more capacity, for a period of time, days, weeks, months, and then drop back to your original rate. And if you want more flexibility, you're always usually going to get more flexibility in private cloud over public cloud. There's more ability to secure up situations and networks, whereas you're not having to worry about the whole world being able to hit your UI or anything like that. So, you can, a cloud provider can offer more capabilities for a company to be able to manage certain things. Usually security is going to be a big one, so that one is the primary reason people are going to be wanting to use private cloud. And also, when you're doing private cloud, like I said, the provisioning, sizing, and things like that, most of it leans on the shoulders of the cloud service provider, obviously with specific input to sizing requirements, table size, so on, head count size from the actual end user. Security responsibilities will vary based on the provider that you're looking looking at, but there's always going to be a lot more options available for security than public. Public is a one-size-fits-all. Here, same diagram that I showed before, from the standpoint of security responsibility, and as I've been mentioning through here, and I do mention over on the side, we manage, even at the application, what's public facing, we're controlling, we're doing the penetration testing, the vulnerability scanning, the probing that all of our customers are safe and secure, obviously all the patching and everything else and all that. But the security for the application, you are allowed to have access controls and things like that. And for some of our customers, if they wanted the ability to do scanning of our cloud, as long as you notify us, that's not going to be a problem. Just for your instance, you can't scan the whole cloud, but you certainly can scan, your instance where you're being hosted. This is just another diagram showing roles and responsibilities. Infrastructure and security, infrastructure as a service, the bulk of the security will rely on the end user, and the highest level of security is provided by the cloud service provider in the SaaS environment. And PaaS, as I just previously mentioned, is usually in between those two. Some requiring the PaaS software to be secured by the end user. In our case, as I mentioned, we actually provide the layer of security public-facing also. Another diagram just to show from the standpoint, the various different layers and what's in cloud, from infrastructure, facility, hardware, infrastructure, who provides what in there. And I, at the very beginning, talked about different types of examples. Public examples, public cloud examples. Everybody's probably very familiar with email, and it's probably the most popular public cloud application out there, whether you're using, Microsoft or Google or whoever else. There's many different email providers, but that's always public facing. I mean, there is options to do private. Microsoft provides private, and so do many others, but that's when public. Various things like, malware detection, things like that. There's many sites, from the standpoint of providing that through public clouds. Web hosting, obviously, if you want to host something, you can go to, a hosting website, provision something up, and also I mentioned other software like payroll and things like that. Software development is still probably one of the largest footprints of cloud use out there, somewhere hovering around 50% or so. Cloud usage is software developers renting some time, developing applications. Many times they might use it for a matter of weeks, shut it down. It'll save their work, but they won't have access to cloud until they sign back up and start, being billed again. Private, well, we're seeing a lot more, from the standpoint of HR and things like that. Well, some are public, some are private. Many of the larger companies use the private offerings for many providers that are out there. Obviously, ERP and CRM, supply chain management, WMS, things like that. Businesses today are always going to want them on private clouds and not have their applications exposed to the public internet, like I said, except for, say, something like an e-commerce, things like that. And then there's various other things that could be public or private, but, in the case of things like ERP, like our DR and online backup and vaulting and everything else, we do private-based, so it's all privately vaulted and everything else. Things like directory services, Active Directory, LDAP, and things like that, you're typically not going to necessarily expose through public cloud, and a variety of other applications. These are just examples. And this just is from the standpoint of candidates to, what can go to the cloud. Obviously, if you're going to get a tremendous ROI from the cloud based on the fact that, you're not having to go out and buy expensive servers and pay for computing capacities for peak time of the year, or have the capacity there, whether you're paying for it or can burst up, but there can be good economics. From the standpoint of the economics of doing high availability and disaster recovery, it can be very expensive to buy. You're going to have data centers or have locations in various different geographies, buy multiple servers, buy replication software, configure it, and have the skills to actually, or pay somebody to actually maintain it and build it for you. Obviously, there's many commercially available cloud applications, so those out, many times, that's usually, like I mentioned, email is usually a no-brainer today to look at solutions like that than managing them yourselves. Or things that are one-off projects, things like that. I'm not going to go through all of these here, but I think you get the point. You know, that you would analyze what's going to work well for the cloud, where do you get the biggest bang for your buck, and so on. One of the things that we saw and how we ended up with some SaaS customers is when the economy was down back in the 2007 to 9 time frame, when the economy goes down, you have a large increase in startups. People got laid off, whatever, they start their own businesses. So you see, even though unemployment goes down, startups spike. So that's where we gain some SaaS customers. But then over time, they like to usually, you know, as they get bigger, they usually revert to a more economical. Because as you start scaling up to, you know, it might be economical for 5, 10, 15, 20 users to go SaaS, but when you're talking 50, 500, 5,000, it can be drastically more expensive than buying a software license and doing platform as a service or infrastructure as a service. Here's situations where, you know, where you're either going to be hybrid, like say shop floor applications that control conveyor systems, things like that, you know, or robotics in a warehouse or shop floor or things like that, manufacturing. You're always going to have some level of local computing resources controlling that, but there would be hybrid and connect up to, say, an ERP system in the cloud. But things like shipping systems, document imaging, you're going to see just based on the bandwidth requirements and based on, you know, if you're doing raw images going up to a cloud, that can be a massive amount of bandwidth. And if you're using, say, metered billing or storage, you're paying metered for imaging going into the cloud, that can be many times expensive to store a lot of document management images. Or it could be a hybrid configuration where ERP might be in one cloud and you might have document imaging in a cloud like an AWS or something like that. So there you might not necessarily be, you know, there's various different things and options to look at. Obviously, large companies that are regulated by certain regulations, there might be certain things that aren't allowed in the cloud that have to be, you know, secured. So, all right. Other things to consider if you're going to move to the cloud, we cover this a lot with people. You know, you have to look at the availability of your bandwidth. If you're running something like ERP, the best choices would not be something broadband-based. Many people don't understand when someone says fiber and it's broadband and it's fiber to dedicated circuit, they're two completely different types of networks. Broadband is contention-based, where you're sharing the bandwidth. You know, consider it something like a multi-tenant type configuration where everything is being shared, as opposed to a dedicated circuit, and the medium doesn't matter, whether it's fiber or copper. It's whether or not you're getting dedicated bandwidth. If you're buying a circuit and it's 100 meg or 500 meg or a gig, you're going to get that speed. It's guaranteed that there's an SLA, you're going to get that. Whereas broadband, there's no SLA. It'll go up and down based on consumption. And if you're looking at, I mean, those might make sense for certain locales where that's all available for a small location, or as a backup circuit or something like that if your primary fails over. But as a primary circuit, that can be questionable from the standpoint whether it's going to suit your needs. Other things to look at, you know, seasonality and demands on circuits. You would always want to have redundancy if you're moving to the cloud, meaning in our case, we would always say you need to have 2 internet service providers. You should have redundant firewalls, and preferably behind those firewalls, it'd be nice to have dual stacks so that you don't have any single point of failure. And also from the things like infrastructure, network infrastructure, things like that, maintaining malware software, anti-malware software and things like that, those don't go away when you move to the cloud. You still need to maintain the security of your network. This is just a short recap of, you're having to inventory what you're moving to the cloud. That's where you're going to start. I'm not going to go through all the details here. I covered these in a lot of different types of other presentations. But there is a lot to consider, how things are going to access. Are you going to have people with mobile devices that are accessing clouds, things like that, various different other things. Certain things like PCI compliance. In the case of our cloud, we don't allow certain information to be stored in the clouds, like credit cards and things like that. We require you be using a tokenization, and preferably one of the more modern methods of doing credit card processing, where you're using a credit card gateway, where the gateway is a web object of some sort, where the actual credit card information that a consumer is putting in is never actually going into your network or our network. All we're receiving is auth codes and tokens. This just goes a little bit further, as to the qualifying moving to the cloud. And a lot of this is, from the standpoint of looking at all your existing operations and everything else that are there. And as I mentioned, from the standpoint of VAI cloud, and we always include HA. If you're moving to other clouds, you'd want to find out if you're providing HA, and also from this, and if it's included, and from the standpoint if the HA is where's the other data center that it would be, what part of the country, what NERC it's on, meaning the power grid is it on. So those are things that you'd always want to find out about. Obviously, in the end, obviously, moving to the cloud should increase your protection, your security profile, your risk mitigation from the standpoint of, malware and so on. Obviously, you still have to protect your desktop from malware and things like that. And we have means in our software, like to eliminate things like SMB, with our later versions of software using a secure model for accessing things on the IFS, like HTTPS protocol, and we have our S2K documents applications to reduce, any types of risk. Obviously, you're not buying a service, so upfront server costs aren't there. So you're just starting with monthly costs. Typically, it's a faster time to deployment. So, and you can utilize public and private. You're not stuck and bound into one. Ours is private, but we have customers talking to other public clouds all over the place. You obviously can scale up and down, without any downtime. That's just something that can be done on the fly. Also, from the standpoint, you gain additional benefits, usability capabilities, in cloud-based applications. It's clientless, ours is just web browser-based. So, others might be thin clients or things like that. And obviously, from a finance standpoint, you still have your CapEx when you're doing platform as a service or infrastructure as a service, because you're buying or owning those applications. So they move towards, they will count towards CapEx. OpEx is usually what your cloud services would count towards. All right, this usually the most common one we see is from the standpoint, if today's tight labor markets and trying to find IT people, obviously eases the burden of that. Modern applications today are multi-tiered. Our application sits, our ERP sits on RBMI with DB2 down there and model levels there. But we have middleware, we have front ends, which are HP servers, and there's many different levels of our application tiers, and it's virtualized. So, those are skills that you have to have if you're doing it on premise. Also, by moving things to the cloud, you'll get to go after all the projects that you never had time with because you're always managing your own infrastructure and so on and so forth down the list. From the standpoint, if you don't have high availability, you gain high availability and disaster recovery planning capabilities. Also, from the standpoint, it might help with certain regulations and so on down the road, depending on what type of cloud, the clouds we have. They're FedRAMP, and they have various different SOC levels and security levels and so on in there. There's other things, from the standpoint of cloud that doesn't necessarily apply to ours, but, certain types of capabilities that you could never afford are available in the cloud. Like you can go to IBM's cloud and have access to their quantum computers. I mean, usually that's for a scientist, but it is something that they can get access to a quantum computer just by paying for some time and compute capacity.